Welcome to our webcast, The New Paradigm in Manufacturing, the Manufacturing Office. My name is Julie Rize, Vice President of Marketing at Rize, and I'll be your host for today's webcast. McKinsey Global Institute reports that of the $12 trillion manufacturing industry, $800 billion per year by 2025 will be direct manufacturing and tooling. And of that, 50% or $230 billion to $550 billion per year will be 3D printed. Despite this colossal market opportunity, most of today's industrial-class 3D printers are suitable only for prototyping and tooling and must be situated in additive manufacturing labs due to their size, expense, special facility and equipment requirements, and complex pre- and post-processing methods. Currently, only a few systems, Carbon, HP, and some metal 3D printers, are capable of addressing the market for low to mid-volume manufacturing parts. And although these companies are undeniably legitimizing 3D printing for manufacturing, their systems come with significant limitations that restrict the large-scale adoption of and applications for 3D printers in direct manufacturing. In this webcast, we'll discuss how 3D printing has the potential to increase large-scale adoption of the technology for new direct manufacturing applications beyond the additive manufacturing lab and explore what's needed to get there. The factory of the future, your office. In order to significantly expand manufacturing applications and markets for 3D printing, the technology must break the chains of the additive manufacturing lab and move into the production facility of the future, the manufacturing office, wherever that office is located and whatever form it takes. There's an enormous unaddressed market for producing customized one-offs and low-volume manufactured end-use parts and tooling on demand in both lab and non-lab environments, including the mechanical engineer's office to make real functional parts, on the manufacturing floor next to the assembly line to make custom tools, jigs, and fixtures on the fly, in the factory to make spare part replacements on demand rather than in bulk years earlier and stored, in the dental and medical and audiology office to produce dental devices, surgical guides, and hearing aids uniquely tailored for each patient, the mechanic shop to make replacement parts, on ships, in air, on spacecraft, and in military field locations for field repairs, and more. The manufacturing office is a new paradigm in manufacturing because existing manufacturing-capable 3D printing systems are unable to address this market. It's simply inefficient and impractical for them to produce one-offs, given their size, price, and complexity, and they certainly aren't systems that can be located in an office or in other remote non-lab locations due to their materials, processes, and post-processing requirements. Prototyping-capable 3D printers, representing the majority of industrial-class 3D printers today, can't produce parts with the required strength, surface finish, heat deflection temperature, color, and other properties that would be considered acceptable for manufactured end-use parts. Further, these systems involve steps throughout their processes that can't be done in an office and in remote locations outside of a specially equipped additive manufacturing lab. With the deafening burst of the consumer and hobbyist 3D printing bubble over the last couple of years, some large companies that previously offered a low-cost line of desktop 3D printers targeting this audience wisely abandoned those lines in favor of expensive industrial-class manufacturing machines suitable for additive manufacturing lab environments. Yet other companies have taken a different approach. These companies didn't change their machines. For them, the shift has purely been a marketing one, where they're selling their hobby-class desktop 3D printers previously marketed as consumer 3D printers as low-cost commercial-grade systems. Still, other companies have made some minor changes to their hobby-class machines or software and labeled them professional or commercial 3D printers, more for marketing and sales impact rather than meaningful enhancements that would benefit the typical industrial user. However, these machines are not suitable for manufacturing and other industrial use, either in the office or in the lab, due to insufficient part strength and material properties, messy and time-consuming post-processing methods, substandard part quality, printer reliability and durability concerns, inadequate build volume, and harmful particle emissions, among other factors. Rize's ability to efficiently produce customized one-offs and low volumes of end-use parts anywhere and anytime makes it an ideal complement to manufacturing-capable machines operating in labs building low to mid volumes of end-use parts. In fact, overburdened additive manufacturing lab managers are not only happy to use Rize 3D printers in their labs, they'd also like to place them in their engineers' offices to reduce their own workload and put parts directly and immediately into the hands of the people who need them. According to Gary Rabinovitz, additive manufacturing lab manager at Reebok, a zero post-processing and environmentally friendly 3D printer would enable our designers to 3D print themselves and reduce some of the workload from the lab. Many lab managers already have initiatives underway to place machines in their engineers' offices, but until now, they haven't had a suitable solution. Rize 1, powered by our patented APD process, is the only industrial-class Office 3D printer enabling the new manufacturing office. Thank you for attending this webcast. Please visit our website at www.rize3d.com.